and then minimize this window. And you're golden.
Perfect. All right, here we go. So today we're going to learn a little bit about just brief introduction into doing data analysis in Python. So have any of you used R before? Okay, and then have any of you guys used pandas in Python before? Yes, a little bit. Okay, so you haven't at all. Okay.
That's why I'm here.
Cool. No, so you've all used R, so you all know what data frames are, and so that's essentially what the Pandas library in Python does. Is it brings that capability of that type of an object into to be able to use that in Python. So it's really good if you have heterogeneous data, and so. At least those of you coming from like a humanities or a biology background, oftentimes you'll have numbers mixed with strings, for example, inside a CSV file, and you want to bring that into Python to do some analysis, and this is when it's really, really powerful. If you're working purely only with numbers, then you probably can get by on NumPy and don't have to worry about learning this new library. But if this is, if you're working with heterogeneous data, this is a really good library to use. So we've got an Etherpad set up for today. So if you guys want to go there, I have a couple links. So the Etherpad URL is right here at the top. And we need to download this data. And if you could save it on your desktop, then we'll be able to access it from there. I'll do the same thing. So when you click on that link, it might look like this. So you could do File, Save As, or I think if you're on the link, you can right-click on it and say Save Link As. And you can put it on the desktop. So
10 megabytes. This is big data.
It's big data.
Compared to these sample data sets, this is a big scale.
So what I'm going to do next is we're going to, has everyone got it saved on their desktop? Give me it's downloading now? Okay. I think mine is still going to. I'm going to close this. We'll just wait a sec.
On campus, the internet, 5 p.m., amazingly fast.
Yeah, not right now. Sorry, how many megabytes did I tell you guys to download?
10.
Well,
10? Okay, it keeps going.
No, I'm at 25.
You're at 25? It might be bigger than that. Maybe I have a USB stick.
I'm looking for data. There's no file size on GitHub. 22? I don't know why I'm down because I'm reaching 30 now.
I thought this would go faster. Apologies. Let me just take a look here. My GitHub account. Let's see how big it is.
Do you have the repo on your computer?
I do. That's what I'm thinking. If I have a stick, I can pass it. I usually have. Yeah, perfect. Ah, it's already on here. Great.
How big is it?
95, yeah.
Like halfway.
So if you want it off the stick, it's there. And I'll just copy it from my computer.
Is this some of your actual?
This is some of my actual data, and this is like this is not. This is a subset of an actual experiment.
Okay. So
Yeah.
this is the C. elegans.
Yeah, exactly. So this will be worm data, and this will be times. Yeah, maybe I'll take a minute to explain the data. So this is going to be basically data of C. elegans behavior collected using what we call the multi-worm tracker. So that's a computer vision system that will take the centroid position of the worm, how fast it's going, different aspects of the behavior over time. And so for each worm, the resolution that we get is 25 frames per second. So we end up with quite a lot of high resolution data. And so that's, I think we only have 2 different strains in here and maybe only 2 replicate plates from each. So a very small experiment, but it's still a lot of data. Okay, so where have I got it on my computer? Here. Lessons, pandas. I'm actually going to need the stick too because I somehow deleted it from my file. Thanks. Perfect, that's way faster. Okay, so what we're gonna do now is we're gonna open up a terminal window on your Mac or a Git bash on a PC, and we're gonna navigate to the desktop. So you should be opening it in your users directory, so we should all be able to go cd desktop. And we're going to use an IPython notebook to do this. So we type IPython notebook. And when we launch this, we're going to launch a new untitled notebook. So I'm here on the right-hand side, click New, and then Python 3 notebook. Great. So I am just going to toggle my head bar so it's a little bit easier to see. Okay, perfect. This looks better. And the font okay for you guys up here? Great. Okay, so the first thing that we're going to start to do is just add the libraries that we're going to need to work with for what we're going to do today. So we're going to load libraries. And the ones that we're going to use are going to be pandas, of course. So we'll import pandas, and we're going to use the PD alias. And we're going to import, we might also need NumPy for some of the things I have planned. So we'll do that as NP. We're also going to use, do a little bit of plotting. So because I want the plots to show up in the notebook, we're gonna use some magic that will be matplot lib inline so that we don't have a pop-up window for the plots. Instead, they just show up in the notebook. And then the last thing that I'm going to add here is just some options for my display for pandas so that it doesn't, when I show a data frame, it doesn't like zoom off the screen. So you can or cannot use, you don't have to use these, but so do that. Okay, so I'm just going to have it maximum rows of my data frame will be 4. You could change this to whatever you want it to be. And I'm just going to add a few cells so that I have them. Okay, so the first thing that we want to do when we're working with some data is get data into the notebook. So we're going to load the data. I just want to first make sure that I'm in the right place. So I'm just going to use a little magic to tell me that I am at the desktop. That's great. And another little magic to tell me what is where I am so I can make sure that I see this file behave2.dat. So if you type ls and you see these 2 things, that's perfect. If not, you might have to direct to wherever the data you save the data on your computer. Okay, so to load a data frame, we will use the pandas read table function. So we're going to load that, and I'm going to call the data frame that we're going to create called behave, and we're going to say pd.readTable. And before I finish typing it out here, I just want to show you, because we're in the notebook and using IPython, we can use tab completion. And Pandas has a lot of different read functions. So if you hit tab here, you can see a few of them. So you can read directly from CSV. We're going to go from read table because I have a different delimiter that we're going to use, not a comma. But you can read, for example, also HTML from websites. So if you want to grab stuff from a table on a website, it's really useful. And you can even read from your clipboard. So something that you copied from your clipboard, you can put in. So that's kind of cool. OK, so read table. And then the read table function, we need to pass it two things. So we need to pass it the name of the file. So the name of the file we've got is behave2.dat. And then I have to tell it what separator we're going to use. And so this is a white, I'm going to use this basically saying we're going to separate based on white space. And it could be one space, it could be two spaces, but this is the type of separator that we're going to use. Although I think that created, last time I taught that, I think that created an error. Let me just peek at the file again to make sure that I'm doing the right thing. That's maybe not what I wanted to do. Yeah.
Could you just use space?
I think maybe we'll just use space because I think I have some missing values in there. And
oh yeah, that's super annoying.
yeah. And so we'll see what happens. We can come back and change the separator if we think that it's inappropriate. But I do remember, yeah. Yeah, of course. Yeah. Yeah, so the set options here, it's not something you have to do, but sometimes it's nice in the notebook if you're presenting or you're teaching. Let me know when you've got it and we'll move forward. Good?
Yeah, sure.
Okay, no, if you have some questions.
No, I just need to write it.
Yeah, no problem. But you've got it typed.
Sorry?
You've got it typed?
Yeah, but it's like, but I need to change my other two.
Okay. If you're not in the right directory, you can also, instead of changing your directory with magics, you can just point to the file here. So like if this is in a different folder, we could use a path. Yeah.
How do you change the directory? You just
You could
sell magic.
Yeah, you can do cell magic. I don't recommend doing that. I think it's better to basically make it apparent here what you're doing. Okay, so we've got the data loaded. Let's take a little peek at the data. So we can type the name of the data frame. And if we just run that, we can get a nice little preview. So usually when I'm using the notebook or using Python, I try and be more explicit. I use print statements to explicitly say I want to output something. But when you use a print statement in Pandas, it doesn't format things very nicely. You get this instead. So I recommend when you're using Pandas to not use the print statement because you get a nice table instead. So what we've got going on here, so again, this is time series worm data from worm behavior. So we've got a column here that is date. So this is the date the experiment was performed on. And then plate. So each plate contains 50 to 100 individuals. And I think there's about 4 different plates in the experiment that we've got going on here. This is time. So it will start when the experiment started all the way up to the end of the experiment in seconds. Then scrolling along here, we have strain. So we have wild type animals, and I just made it simpler for this example, just mutant 1. So we have only one mutant we're comparing to. The frame, and then if we go along here, now we have information about different measurements that the apparatus has given us for the experiment. So the area, for example, how big the worms are, how fast they're going. We've got some missing values at the beginning of the experiment, and many, many different other things. Okay, so the next thing that we wanted to look at is, let's take a look at the different types that are in the data frame. So to take a look and ask for what are all the different types that exist in the data frame you loaded, you would type behave, so the name of the data frame, .dtypes. And if we take a look at this, we can see that when it looks at date, because it contains all numbers, it calls this an integer, so it's int64. If we take a look at some of the later columns, so some of the last columns, orient or crab, they all contain decimal numbers, so it decides to call it a float. But interestingly, when you look at something that's plate, where you have integers and then some other character, it doesn't necessarily specify it as a string. It calls it a just an object. And so if you want to, this can kind of catch you up in Pandas, so that's kind of the default. It will become an integer, it will become a float, or it will become an object. And so if you want to do some downstream analyses, you might have to convert this object type to something else. Just something to watch it for.
Is there an option in table to kind of change that behavior? Just like string as factors?
So not that I'm aware of for loading, but there might be. There is different. So you can definitely type things afterwards. I don't know about when you're loading things. Yeah. Okay, so if we want to, for example, just grab a single column from the data frame. So say we wanted to grab, scrolling along here, I can't see all of them, but we have a column called morph width, which is, I think, how wide the worms are. If we want to grab something, what we do is we type the name of the data frame, and then we can use square brackets, and we can put the name of the column inside there. So I start typing morph, and really nice thing about Pandas is it knows about the column names, so I can hit tab and it will finish typing in the column names for me. So that's really great. So I can just call that. And then what you get is basically a list, or not a list, but an array, or it's called a series really, of the measurements that were in that column. And then you also get these numbers as well. And so these are the index. So you see this, if I scroll up a little bit and we take a look at the data frame again, if we were to look at this data in a plain text file, we wouldn't see this column. This column doesn't exist. This Pandas just adds an index column. And so right now it's kind of a silly index. It doesn't really mean anything. They're just basically like row numbers. But you can move different columns that exist in the data frame in and out of the index and use those to sort more quickly, or use it to do different type of, in the case of time series, we'll see, do some sort of interesting time series manipulations. So when you only ask for a single column from Pandas, the object type changes from a data frame to a series, but a series is different than an array, for example, from NumPy, because it has this index that comes along with it. Okay, so we can also access multiple columns. So if we wanted to access the strain along with morph width, we would type behave, and then we have to use 2 square brackets and give the first column that I want, strain, and then the second one, which would be morph width. Spelling that right. And then when you ask for those, now because you're asking for 2 columns, you get a data frame, not a series.
Sorry, I missed that. Why do you put 2 square brackets?
Why do you put 2 square brackets?
Or is it because it's a list?
I think because it's a list.
Okay.
So this is a list of the column names that you're giving. So it's not like if you wanted a 3rd column, you don't add a 3rd set of brackets. You just keep those 2 brackets. So for example, if we throw area in there, we still only use those 2 brackets. Yeah.
I'm curious to know if you can put a 2+1.
So what do you want me to try?
I'm curious to see if you can put a tuple. No, never mind, you can't.
Yeah, so you're trying to say like access by column numbers?
No, like just instead of using
Oh, a list in here,
use,
so
like square brackets, but
like,
I think
yes.
errors out online.
Okay.
It would be
Yeah, no, I get an error as well. It's expecting a list.
okay.
So that's how we can access the two different things. If we wanted to know, for example, how many strains that we have to deal with, I know because I made the data set, but if you were handed this data set and you didn't know how many strains and we've got 500,000 rows, how can we figure that out? We can use the set function. So we can say set behave and then pass it a column, strain. And it will tell us that there is mutant and that there is wild type. For example, if I was interested, also I said, I think there's 4 plates, but I can't remember. I could do the same thing. So I could say behave, and then I could say plate. And yeah, no, I'm correct. There's 4 different plates in the data set. So this can be something that's quite useful to do. Okay, so in some situations, you want to access maybe not necessarily the columns by name, but you want to access them by the column number for whatever reason. You can also do that in Pandas. So you can, but you have to use the iloc method. So you would say the name of the data frame, and then you say iloc. And then we could grab, for example, all the rows from the 3rd column. And if we do that, then we get very similar thing to grabbing the column if we're using the name of whatever the 3rd column was. I don't remember.
What is iloc supposed to mean?
I'm guessing like integer location, maybe. I don't know, but it's different. And there is a 3rd way, I think .ix, that you can access things that is more like slicing. So if you do, I think it's this. Yeah, so there's also this. There's 3 different ways to kind of access numbers. And my Pandas expertise does not go super deep, but there are certain situations where this one is the only one you could use, for example.
Okay, I see.
Yeah. So we can use this slicing not only to grab all of the columns, we could use it to grab, say, like the first 10 columns. So we could do that. And then we only grab, first 10 rows of the 3rd column. Yeah. I think it might be, I'm just going to test something. I think it might be the range, but does that work? No, that works. Yeah, I can remember the differences why you need that sometimes. Okay, so one thing that's nice about Pandas, and it's similar in NumPy, is that because you have these different data structures, if you wanted to do mathematics, Pandas will do element by element wise mathematics. So if you wanted to take one column and add it to another column, it will take the first item of column 1 and add it to the first item of column 2. It will take the second item of column 1 and add it to the second item of column 2, and so on and so on. And so that can be really handy. So we can just do a simple example of that. I'm just going to add some more cells. So let's just take a peek at the, I'm going to show you the 2 rows that we want to act on. So I want to take a look at morph width. And the other one is midline. What am I doing wrong here? I'm spelling wrong. There we go. So essentially the midline is how long the worm is, basically how long, and the morph width is how wide. And if you divide those two, you can get an idea basically about the shape of the worm. And so we might be interested in that to say that the worm is turning, for example, as opposed to moving forward. And so we could create a new column that we would add to this data frame. So to create a new column, you would say the name of the data frame, and then square brackets, and then the new column that you want to add on. So we're going to call this mid-width ratio. And then we'll say that that is equal to, and now we can essentially use the columns in the data frame just like individual numbers and know that it's going to do element by element wise mathematics. So we would say that we're going to take the behavior data frame and we're going to access the morph width column. And we're going to divide that by the midline column. And then after doing that, I am going to print out morph width midline and the new column we made. So in, very simple steps, we were able to do a lot of mathematical operations. And this is a very simple one, but it can get much more complex than that. And so you can see that it's nice. How are we doing for pace? Is this too slow, good, too fast? Perfect, okay. Okay. So just for example, if you were to time this operation on 500,000 rows and you were to do it using element-wise mathematics, it only takes about 50 milliseconds. If you were to write a loop to do this, it would take you about 2 minutes to do the same amount of work. So Pandas and NumPy both use some much faster mechanics under the hood that you don't see that lets this happen more quickly. So if you're going to be doing any mathematics with like large arrays of numbers, you really want to be using NumPy or Pandas to do that.
Yeah, if ever someone in the audience were to ask, like, wow, I can do this in Excel, why use Pandas? Like,
why use this instead of Excel? Well, right now we're dealing with 500,000 rows of data, and this is moving along really fast in Pandas. If I loaded this into Excel on my computer, it would be going a lot slower. Yeah. So performance in Pandas is a lot higher than it is in Excel. Yeah. And second, it wouldn't even load 500,000? Okay.
It exceeds the limit.
Okay, it exceeds the limit. Okay, so we can, yeah, okay, so that's a good answer. And also we now have a record of, as we're creating this notebook, we're creating a record of everything that we did. And I think that's really valuable.
Okay, that's good. Yeah, because I want to be able to have arguments against using it. So I want to build up my arsenal. Like, don't use Excel.
Yeah. Well, just at some points you just can't, right? Like, like the memory aspects, you just can't. And
I like because some people deal with much smaller data sets, and I want to be able to convince those too. I don't want them to convince only when they can run it. But the idea of, like,
no. So I think having a record is really, really valuable and really important. Somebody knows. It's not even just manipulating your data frames. When it comes to plotting, you have a record of exactly how you made that plot, and also saves time. Like if you're going to be working with similar types of data sets, it's really easy to just load different data sets into the same, say, notebook and just run all the cells and have the same output. So it can be nice. Scripts are even better, but we're not going that far yet. Yeah.
This is because it makes everything look good.
Yeah.
And you can export a notebook as a script afterwards.
Exactly. Okay, so one thing that I said, another thing that's really nice, so taking a look at this data frame, this is a subset of our big data frame. Remember I said that we have this index column that is kind of silly right now. It's just the row numbers. We can make this more useful. So we can maybe put our time column as the index, especially because this is time series data. And then we can use some powerful functions in Pandas that will let us, for example, like downsample the data, and from like, instead of going at 25 frames per second, maybe we can take averages over every minute, for example. And that's something you commonly want to do with time frames. Maybe you're not working on this small scale, but if you're working on, like with dates, multiple measurements for many years, maybe you want to look at yearly averages. And so this would be, this kind of strategy we'll show you next would be very useful for that. Or if you're looking at even larger time scales, decades, you can also tell Pandas to basically resample your time column, your date time columns into nice chunks of whatever you really want to do. So this is one of the examples where I do know how to do something when you're loading the data. So I'm going to show you how to set an index when you load the data. So we're going to reload the data. We're going to overwrite this data frame. So we're going to, again, use the read table function. And so again, we have to give it the name of the file. So I think it's behave2.dat. And the separator, again, I think it worked well with just a single white space. And then the next thing we want to give another argument is I want to tell it which of the columns in the data frame we're loading we're going to put as the index. And so I can say index column or call is equal to, and then you pass it the string that's in the header of whichever column that you want to be in the index. And so for us, it's going to be time. And so I'm going to add to the next line just the name of the data frame so we can take a look at what happens when we load it this way. And I think it probably takes a little bit longer to load. I have the numbers down here because I did calculate that before. So that should have taken on my computer about 4 seconds to load. And when I loaded it the first time, it was 3.5 seconds. So it takes half a second longer to make the index. But if you're going to be sorting on this index column a lot, it makes your sorting a lot faster afterwards. And like I said, it's going to let us do some things that we weren't going to be able to do before. So now, instead of having these silly numbers, they're gone, and our time column is come down. So one thing that I've had people have a misconception about before is that this row doesn't really exist. This looks like a blank row, but it doesn't really, there is no blank row there. Like if you ask for the 0th row, let's just do that. So if we say behave, and we want to grab, I think we have to use .iloc. We want to grab the 0th row and all the columns, or let's grab the first 5. Is that what I want to do? Yeah, that's kind of what I want to do. Maybe I can. What we see is when we grab the 0th row, we get information. So it's not that this is not the 0th row. This is the 0th row. They just offset the visualization of the data frame that way, so it makes it really clear that it's the index. But that can lead to that's been a misconception that I've experienced with people. Okay. So, any questions so far? How are we doing? Good? All right. So, we can ask what the type of the index is. So we can access the index by saying the name of the data frame, then .index, and then we can say ask for the D type. And we get right now that the D type is a float 64. So if we go back up and peek, yeah, these do look like decimal numbers, so that seems reasonable. But I told you that this is a time series, and we want to take advantage of some of the time series functionality of Pandas. And so what we're going to do is we're going to convert this from a float object into a date time object. And so from that, we'll be able to use some functions like resampling. So to convert it to a date time, you can do this with any column. It doesn't have to be the index. We're going to reset the index. So we're going to say behave.index is equal to, and then we use the pandas function to date time. And so we'll say behave. First thing we give it is what we want to convert. So behave.index. And then the second argument we give is what is the unit. So we have to say, like, this is a float. So is this like, are we passing it minutes? Are we passing it seconds? Are we passing it microseconds? So in this case, what we're passing from this experiment is seconds. So that's what we'll tell it. And so we run that. And now when we ask for the D type of the index, we can see that it's different. So it's this different date type that allows us to use the next function that we're interested in. So now when we look, let's just take again another peek at the data frame. So now we see that this looks more like a date time object. So it has year, a month, a day, as well as a time. Arguably, date time is not necessarily appropriate for this data set because, or at least for this column, because it only had seconds. It doesn't like the year. It's like when the experiment started. So like the date of the year doesn't matter. So there is another time class in Pandas. It's called time delta that we could have converted it to. But there's a bug in Python, Pandas that exists right now that doesn't let you plot effectively with it if you use that one. So right now I'm having to use date time, even though it's not really appropriate, but it lets me do what I want to do and take advantage of all the functionality of having a time object. And so we'll just go with that. And it just puts in this date because I think that's like basically the default for like Unix dates if they have to create one. Okay, so what we want to do now, so if we take a look at this, so this is 500,000 rows, and like I said, this sampling is at 25 frames per second. And when we go to plot all of this, it might take a really long time to plot every point for that. And so maybe we only want to plot the points for every 10 seconds. So what we want to do is resample the data so that we, for example, take the mean on 10-second time intervals. And then we can plot that. And so that's a little bit easier to deal with. Or you might be interested, what is the average over 10 seconds? Because you might expect some variability and you want to see just what the average is on that time period. So we use the resample function to do that. So what we say is, I'm just gonna add a few more cells. Okay, so I'm gonna make a new data frame that's gonna contain this resampled smaller data frame. So I'm gonna say behave resampled is gonna be equal to behave, so that's the original data frame. And then we're going to use the resample method. And what we pass to resample is we say, what is the time interval that you want to go on? So we want to do it on 10 seconds. Or you can pass it 5 minutes. You can pass it decades, whatever. If you go to the Pandas documentation for the resample function, it will give you a list of, or basically information of all the different things you could resample by. And then the next thing you have to say is, how do you want to resample? So there's many different ways if you're reducing the data that you could resample by. So here we're saying mean, but you could say maximum, you could ask for the minimum. Yeah, there's a variety of ways. So we're passing it some function that we want to resample. And then I'm just going to move to the next line and ask it to show me what the data frame the new data frame looks like. So when we do this, I'm just going to scroll down, we can see now if we look at the bottom here that it's only 24 rows of data. So it's greatly condensed our data, given us the average for all of the numerical values in our data frame for every 10 seconds. You can see we've lost, have we lost? Yeah, we see the one that we've lost is
because they're objects.
Because they're objects, yeah. So yeah, I think they're gone because we haven't really told Pandas how to deal with those non-numerical columns. So we'll get to this later, but maybe you don't want them to disappear. Maybe you want the 10-second averages for the wild type, and then you want the 10-second averages for the mutant. You don't actually want to collapse them. That's what we've done here, right? We've collapsed it for both the wild type and the mutant, and that's not essentially what we want to do.
Is there like a group by?
So that's exactly what we'll do next. So if you want to preserve one of those columns, you might not want to preserve them all. Like I don't necessarily at this point want to preserve the plate information. For my next application, I don't think that's meaningful, but I do want to preserve the strain information because I want to look at the strain differences. So then that's what you do. So yeah, we'll move on to doing that next. Okay, so let's make let's group by strain, and then when we do this, we can have a resampled for both the wild type and the mutant. So let's make a new data frame, or a new object, sorry, called grouped behave. And what we're making here is what's called a group by object. It's not a data frame. This just contains the information about the groups and their relationships to the rest of the data frame. So what we do to do that is say behave dot group by, and then we pass in the column that we want to group by. So in this case, we'll say strain, and I'm just going to add on to the next thing, and let's ask, what did we just make? What is the type of grouped behave? So when we take a look at this, so we use the group by function on the behave data frame, and we group by strain, and the type of object we get back is not a data frame, it's a data frame group by object. So what happens if we draw this object? Not very much. So this object is not useful on its own. It's useful when you apply it back to the data frame. Okay?
Okay.
It's just like metadata from SQL.
Yeah, I think you can think about it that way. I don't honestly understand the mechanics behind it, but we can basically use this and apply this to the data frame and then apply some other function, and it will split that function based on the different groups that we've specified. Yeah. So let's do that. So let's move forward. We're going to create a new data frame called resampled groups. We're going to group by strain, and on top of that, at the same time, we're going to chain on the resample method. And so we're going to group by, and then we're going to apply this function resample to get the mean for every 10 seconds. And so we'll get a data frame that has split the two resampled time series by the two different strains. So to do that, we're going to start with some of these resampled groups. And then we're going to go back to our original data frame, and we're going to apply the group by. And we're going to group by strain. And then we're going to chain on resample. And again, we'll do 10 seconds, and we'll use mean. And then I'll print the data frame. Mean is not defined. That's got to be a string. All right. So when we take a look at the data frame, we see, again, it's no longer 500,000 rows. Now it's 48 rows. And we see that we have a section that is mutant 1 and a section that is wild type. So we have essentially what we wanted originally. So we have resampled values by 10 seconds for group 1, which is the wild type, and group 2, which is the mutant. Okay, any questions there? Make sense? All right.
So it's like 24 and 24 then.
Yeah, exactly, yeah. It was, 24 time periods, 10-second bins from, I think we go, gosh, I can't remember how long this experiment is. Oh, here it is. Looks like it's a 4-minute experiment, yeah. Okay, so now I'm going to show a little bit of plotting. So Pandas, basically, has anyone here used matplotlib before? Yeah. No? Okay, so matplotlib is a plotting library in Python, and it was based off of MATLAB's plotting library, or plotting functionality. And Pandas has plotting functionality as well, and it really just sits on top of matplotlib and utilizes matplotlib. But it does it in a little bit of a simpler way. So it's really easy to get some quick and dirty visualization plots in Pandas. One thing I have not run into with a little bit of trouble is that if you are trying to like add nice axis labels and make the plot look really fancy, you might be better off to just do it via matplotlib, which you can do by passing in your data frame to matplotlib. But just to do quick, easy things, Pandas can be really useful. So let's just show that. So let's work with the single data frame, not this one that contains both the mutant and the wild type. Let's go back to the simpler example here. So behave resampled, where we collapsed the two strains. And we'll just we'll just plot the average of these two strains. And we'll look at their speed, or angular speed over time. So angular speed is basically how much the worms are turning over time. So to do that, we take the data frame that we want to plot. Oops, where am I typing? So behave resampled. And then the column that you want to plot. So I want to look at angular speed. And then all I have to do to visualize it is type .plot. And if I do that, I get a nice plot that plots my time. and plots the y values on the y-axis. So pretty easy, pretty simple, good way to just peek at the data. If you want to plot everything in your data frame, so what if you just want to look at, you know, potentially how everything looks because you're doing exploratory data analysis, so you can do that as well really easily, more easily in Pandas than you can do with Matplotlib. It would take a lot more work to do this with Matplotlib. So you can say behave sampled dot plot, and then you have to give a little bit more information. So we're going to say subplots equals true. If you didn't say this, it would try and plot everything on the same plot, and if you have different scales, it's not really that useful. And then we have to give a figure size. So I'll say fig size. We'll see how well this one works. We might have to change it. And you have to give it a tuple. So I'm going to say 10 by 12, and we'll see what that looks like. So I'll just keep this here for a sec to make sure you guys have all the text. But what you'll see if we scroll down is all of the different, again, the figure size is not great. Maybe I would have make it way longer so that you can see more. But it plots every single column in your data frame. And so this could be potentially really useful if you don't know which variables you want to investigate later. If you only want to plot a subset, so like 2 or 3 of them, you could say behave resampled, and then use your column subsetting. So we can plot speed, angular speed, and bias, for example. And then we can do dot plot, and then the same arguments. Subplots equals true, and then fig size. I'll try 10 by 8 this time. Hope it's a little bit nicer. And so when you don't have like a ridiculous amount of columns, you can see that you get a little bit nicer, or you make a better fig size for them. You get a little bit nicer pictures. And for this data set, these are really interesting columns to look at because we apply a stimulus at 100 seconds, right about here. And then we can see that these different aspects of the worm behavior is changing. So the last thing, yeah, because we're running out of time, right? Oh, I have that.
How did you have the colors?
Oh, the colors just automatically happened for me. Did you only have one color?
Yeah, black and white.
Maybe you need the newer version of Pandas?
Yeah, I'm downloading it now. You can imagine how long it's
I think actually this, I think this kind of surprised me too, and I have updated Pandas in the last month.
I know that Matplotlib has new defaults for coloring, so maybe that. I'm just waiting for it to download.
And I was going to show you how to plot now both of these, but I am forgetting off the top of my head how to do that. And I think I didn't print my cheat sheet. So I'll see if I can find it and show it to you. If not, I can throw it in the Etherpad afterwards. But essentially what happens when you have these in this group by situation, you have to loop over the group by object and plot them one at a time to get them on the same plot.
Mm.
So that's one way of dealing with it. The other way of dealing with it is if you don't do this group by. The group by can be really useful because, again, you can apply these different methods to it. Here we applied the resampling. Maybe a better way, if you are going to plot with Pandas, is that I think most of the, we'll see if I can do this off the cuff live coding. If we reset the index, or we use the original, yeah, if we take this and I reset the index with this level, so there's a couple different, we have 2 levels of our index here. If I reset this index, I should get another column where each, basically this strain will come out of the index. I should come up here maybe. Strain will come out of the index and be a column. And each row will have a value. And then when I go to plot it, Pandas plotting functions can take an argument called kind, no, not kind, by. And so you then it will split it by whatever column that you gave it that. So we'll see if we can do this.
That's odd. You'd think that this would be very simple.
Yeah, you would think. So I think that the group by is really good for applying many different functions. But then when it comes back to plotting, if you've got this group by object, you have to write this loop that is not super intuitive,
Okay.
At least to me.
Yeah, because if you plot them just as is, like whatever.
No, you get it
you
repeated
basically,
plots.
Like, yeah, plots that.
Yeah, exactly. So here, I'll show them. What did you type again? Sorry, resampled.
Yeah, the group resampled or whatever your name is.
Oh, I can't remember. We're talking about resampled groups. Okay.
And then just took one variable speed dot plot, and it just basically plots one and then switches on the next.
Yeah.
Doesn't make sense in terms of time.
No, so it repeats the axis.
Yeah.
So this would be one group, and that would be the second group. But it doesn't put them on top. And so to get them nicely plotted on top, you have to loop over this object, and that's a pain in the arse.
Mm.
So, but you can do it. So then if you can do resampled groups, and then if it's dot reset index. And so what happens when we do that? I think there's a level. Let's try 0 and see what we get. I'm just going to call this test, and we'll make a new data frame.
That worked.
Test. Oops. So this is exactly what you want to do. So now we have, we had to do the group by to apply the resampling effect to each to split up the groups, but now it's kind of counterintuitive. Now you want to go back and get rid of that as an index, and now we should be able to plot. So if I want to do, so now I'll do test dot plot, and then I want to just do again speed. And then we can say by strain, I think this should work. That one also looked kind of funny. It works for bar graphs or box plots. I have to go to the documentation here.
They just do one strain there.
No, I'm not really sure what happened there. Dot box plot. Yeah, it's because you can do by here for the box plots. DataFrame dot box plot. Okay, let me take a look again. What we've got going on. So you're getting to kind of what's series object has no.
Kind was maybe kind.
Okay. It's not liking that I'm giving it a series. It should have time. Oops. Maybe I have to give it. Yeah, I'm kind of drawing. So maybe here what I'll do is I will subset test. Okay, I understand. I think I have to give it two things. I have to give it, as in addition to speed, I think I have to give it strain.
That makes sense.
Well, let's see if it makes sense. And it's done it over, so now it's averaged over the time. Wonder what it does if we do plot. No, it still screws it up. Yeah, so if we didn't care about it on the time axes, I wonder if I can do 2 bys. All right, and after this, I'm going to give up because we're out of time. Probably not going to like that because time is an index. No, it doesn't like that. So anyways,
it's possible.
It's possible, but it gets a little bit trickier when you start doing that. But yeah, so when you start getting into group by and looking at different things, it gets a little bit trickier. So yeah, the way that I guess I was able to solve this to make 2 line plots was looping over the group by object. And again, I apologize, I thought I had it in my notes. I'll put it in the Etherpad if you guys are interested to see that. Yeah. Any questions before we wrap up?
Yep, no, that's good.
Okay.
Awesome.
All right. Thanks for your time.